Welcome to the screencast for the BioAsk Annotation tool. We developed the tool during the course of the BioAsk project to allow for collaborative creation of benchmark data for biomedical question answering. Therefore, the tool allows for questions to be both created and answered. It allows those questions to be annotated with concepts, documents, text snippets, as well as RDF statements. There is a detailed guideline in the form of deliverable 3.4, which can be downloaded under the following link. And in order for curating those benchmark data, the annotation tool is integrated with another tool called the social network. There's an accompanying screencast about the social network, and I encourage you to watch this one as well. So questions can be published to the social network, and on the social network, feedback can be given to those questions, and this feedback can be then incorporated into the questions on the annotation tool, and by iteratively repeating this process, we were able to achieve a higher quality of questions in the benchmark dataset. The following use cases are covered in the screencast. Question creation and answering. The annotation tool supports both exact or structural and ideal or verbal answers, and questions can have one of 4 different types. There are yes/no questions that are decisive in that they can only be answered by yes or no. There are factoid questions that are answered by a single fact and optional synonyms. There are list questions that are answered by a list of facts plus optional synonyms. And there are summary questions that have no structural answer. The tools also supports performing a literature survey. To do so, we integrated the Go PubMed search services for concepts, documents, and statements. A hypothesis can be formulated using the tool, which is similar to the answer or the ideal answer. And hypothesis can be checked or evidence can be documented. This is done by annotating the question with concepts, documents, and statements, and in particular by annotating with text snippets from the documents. But there are other usage scenarios possible using these use cases. For example, in classroom usage, students could be given questions. Students were then to perform literature search using the annotation tool. Students formulate an hypothesis or answer the questions. They can then hand those answers in using the social network. And a professor can review and grade the answers using the social network. Now let's get started with this screencast. You sign in to the BioAsk Annotation tool by typing your email address and password into those fields. If you do not have an account, you need to create one first by clicking the button Create an Account. Not everybody can create an account though. The use of the BioAsk Annotation tool is limited to a list of email addresses. In order to get your email address onto this list, you need to write an email to one of the administrators. After having filled out that form, you can click the register button and you will receive a confirmation email with an activation link that you need to click in order to activate your account. After your account is activated, you can sign in using the email address and password. Should you have forgotten your password, you can enter your email address and click the Forgot Password button. I'm now going to sign in. After signing in, you will see your list of questions, which is initially empty. Your existing questions are listed and new ones can be created. In order to demonstrate the tool, I will partially recreate a question that was devised by one of our experts during the second year of the challenge. Let me do that now by clicking the Add Question button. Some form fields appear in which I can enter details about the question. The question text holds the question itself, while in question type I select one of the 4 question types: yes, no, factoid, list, or summary that were discussed in the introduction. For this question I will use what are the interaction partners for the protein GATA1, and I will select list as the question type. I click Save and the server automatically generates an identifier for this question. Now that there is a question, our question list contains one element. Each question in this list is displayed as a row with 3 columns. A local counter to show us how many questions are in our list, the question text, and its publication level. The publication level determines whether and to which user groups the question should be published on the social network. Public, which is displayed as an I, publishes the question to all users. Restricted publishes the question only to senior users. Restricted is displayed as a check mark, and private does not publish the question to the social network. Private is the default and is displayed as a lock icon. Let us proceed to the search screen now. The search screen displays at the very top the title of the question that we are working with. Underneath, we find an input field for the search query, a button to perform the search, and a drop-down box that keeps the history of each query. When you hit the search button, the annotation tool will perform a search for each of the 3 result kinds separately. These are concepts, documents, and RDF statements. By clicking on the gray bar, I can reveal or hide the results for a particular result type. Let me enter the first search query, searching for GATA1 and partners. We have already found 207 concepts and 22 documents. A search for statements is still ongoing. I reveal the concept results by clicking on this bar. The concept search is searching 4 different ontologies: gene ontology, GeoChem, Mesh, and UniProt. In parentheses, we see the number of results from each of the ontologies. I can select the results from a particular ontology by clicking on its name. By default, Mesh is selected. Each concept result has a matched label, a score, a canonical label, and 2 buttons. A concept is an abstract entity that can be described by different labels, for instance, synonyms. And it has one label that is designated as the canonical label, which it will be referred by in other parts of the tool. If a term in your search query matched a different label than the canonical label, it will be shown as the matched label, with the matched search term highlighted. I can select a concept result, that is, annotate the question with this concept by clicking the plus, or I can deselect an already selected one by clicking the minus next to the question. If we switch to UniProt, we see that there are at least two concepts with the exact same labels. In such a case, we can visit the little arrow button next to the concept that opens the concept description page on the web. Our first concept is the GATA1 for the mouse, while the second one refers to the GATA1 in the rat. Since I don't want to restrict this question to a certain species, I pick all of them. Now let's have a look at the documents. A document result is displayed by the document's title and the same two buttons that reveal the document on the web or select it as an annotation for the question. I can click the document title to reveal the abstract or the full text if available. Similar to concepts, I can visit the document on the web by clicking the small arrow button, or I can add it to or remove it from my selected annotations by clicking the plus or minus button, respectively. Statements are a number of RDF triples that have been transformed into something that resembles a natural language sentence. I can inspect the RDF triples by clicking on the statement, and I can add both of them as annotations for the questions by clicking on the plus button. Now let's search for a different query. I will use GTA1 and interaction partners. Note that my old query is still available in the query history. This document already has a minus button next to it, indicating that we already have selected it. The answer screen shows again at the top the title of the question that we are working with. Below it, we find a drop-down box to set the publication level for the question and to save the question to the server. Underneath, an input field is displayed where we can enter the ideal answer or verbal answer. We will fill that out later. And we can create an exact or structural answer. At the very bottom of the answer screen, we have 4 tabs, 3 of which display the annotations that we selected on the search screen: concepts, documents, and statements. In order to select snippets, we select the Documents tab and click on the first document. This allows us to read the abstract and the full text if available. And we now try to find some evidence about interaction partners for GATA1. The sentence GATA1 and LDB1 proteins were confirmed to bind to LMO2C by MBD pull-down analysis would be such evidence. I highlight it with a mouse and click the appearing Annotate with Selected Snippet button to annotate the question with this snippet. Additional evidence is given in the conclusion sentence, which says LMO2C can bind endogenous GTA1 and LDB1 protein in K562 cells and downregulates the expression of GPA. So I annotate the question with this snippet as well, because we want to find all the evidence from this document. In the second document, we find that at other differentiation stages, additional combinatorial interactions occurred between RUNX1 and its co-regulators GAT1 and ETS. So again, we highlight this snippet. And now we have 3 snippets found in 2 different documents. All 3 of them document evidence about some of the interaction partners for GAT1. So we can go on and create our exact answer by adding the first list item, which is the first interaction partner and is called LMO2C. And we have another interaction partner, which is called RUNX1. And I can create another list entry and add this interaction partner. In order to form an ideal answer, we could use the sentence, evidence suggests that GATA1 interacts with LMOs 2C and RUNX1. Since I'm satisfied with my question, I set the publication level to restricted and save it.